Okay, so this is Jenna, and I'm going to be explaining the chemistry AMS quiz. Okay, so for the first one, an ion is anything that carries a charge. It doesn't have to be an electron, and it doesn't have to be neutral. It can be positive, negative. It doesn't have to be an electron or neutral. Okay, so here the keyword is charge. So here we have two answers that have charge in them. So we just pick those, but don't go off that. Just like understand the meaning of an ion. Second question. Okay, saturated solution is when you add the maximum, keyword is maximum, amount of solute is dissolved in a fixed amount of solvent at a certain temperature. Okay, the keywords here are maximum amount of solute and certain temperature. Okay, and the other questions here, excess, no. Here 1 mole, no. Here you can't this is maximum, so you can't add any more. Okay, so this is automatically wrong. This is automatically wrong because they're saying 1 more, so they're specifying amount, so that's not maximum amount. And then here excess, so no. So the only one that fits to our descriptions is the first one. Second, okay, precipitation. We've learned it grade 4, grade 3, grade 1, grade 5, 6, 7. We learned it every single year. Precipitation is when you're forming a solution, but while you're forming a solution, a solid pops up for you. Okay, so let's assess the choices. Okay, so here a solid forms. It is for the formation of solids from a solution, so that's right. The dissolution of solid in water, no, you don't dissolve it, so no. Melting of a solid, no, it has to be a solid. It doesn't melt, it doesn't freeze, it doesn't anything, it's just solid. Formation of gas, no, it's always formation of a solid. So that's why that one right. Okay, for this question, it came in the final, so you should know it. But it's pretty simple. Whenever you see 0 Celsius, 0 degrees Celsius, and 1 atmospheric pressure, or they can do 0, they can go like, they can go 0 degrees, why is it not writing? 0 degrees Celsius, and they can say 1 atm. That's the same thing as 0 degrees Celsius and 1 atmospheric pressure. Okay, so it's always STP. I don't think we learned the conditions. We did learn the conditions for RTP, but they never asked them. So if you want to revise over RTP, you can revise, but they never do ask them. Okay, oh, and for STP, okay, like we said, it's 0 degrees Celsius, 1 atm, and it's always 22.4 decimeter cubed. Okay, like whatever amount, 1 mole, whatever, equals to 22.4 decimeter. And then if you have 2 moles, you just multiply by 2. Okay, for this question, I believe part B is wrong because they're asking for it in decimeter. If they add times 0.24, that's when you add 3. But if they didn't, but I believe they did ask, they meant to add 22.4. Okay, but in part B they didn't, so it's wrong. Okay, so the first part A is right though. Okay, so here they're telling you, give your fill in the blanks to give the correct reaction ratio of reactants by product and product by volume. Okay, so in STP, because here they say STP. Okay, so it's always times 22.4. Okay, so the first one here we have 2 moles, so it's 2 times 22.4. In the next one, we have 7 moles, so 7 times 22.4. And in the Third one, we have 4. So 4 times 22.4. And these are all these. Okay. And something about volume. It's always negligible if it's liquid, okay? It's always negligible. So here they're telling you to put a 0 if it's negligible, okay? So let's look. Here they're telling you 6 molecules or 6 atoms, moles, whatever, of water. Water is a liquid. What did we say about liquid? It has a negligible volume. So we put 0. Okay, here they're telling you select the side on which energy is placed in the following reaction. They're telling you it's an exothermic reaction. Exothermic means it releases energy, okay? So it's gonna be on the product side because released is in the product. So it's gonna be on this side. Whatever is behind an arrow, that means it's products, okay? And here they're telling you 1 mole of H2 releases 284 kg of energy. So let's put 1 here, 1 mole, and 284 kg. Okay. What will 2 moles release? So we just cross multiply. We can do that, or it's just common sense, okay? So 2 moles times 284, you can use your calculators, it's 568. Okay? Okay, sublimes is sublimation. I believe your teachers gave you at the beginning of the term 1, the like states from which to which, or like whatever like, you know. So sublimation is from solid to liquid, to gas, sorry. Okay, so here they're telling you it's sublime, so it's the same thing as sublimation. So you put solid to liquid, solid to gas, sorry. If you don't remember it, S for solid, S for sublimation, okay? And then you just have to remember gas. I remember it because it's weird and it starts with S and it's S, okay? Okay, so for this question, they're telling you to complete the equation below to present the dissolution of NaCl in water, okay? Water, we don't need to write H2O, okay? The arrow signifies water, okay? So, the dissolution of NaCl. NaCl is an ionic compound. So that means, wait, I'll just, CM compound, yeah. CMP stands for compound, okay? So when NaCl dissolves in water, it produces ions. So whenever they're telling you to write an equation of an ionic compound, that means you have to add the plus and the minus, okay? So here, in the exam, they're going to give you a periodic table, but in the quiz, they didn't give you a periodic table. So I'll be your periodic table, okay? Na is in group 1. Group 1, okay? So that means it gives off a 1 plus, what is it called? 1 plus ion. So Na is going to be +1, okay? The number is always before the sign, okay? And then Cl, okay, is in group 17. So it's gonna give off a -1 minus, okay? Whenever we have 1, you don't need to add the 1, you can just put minus. So that's that, okay? And then whenever you're dissoluting or whatever, dissolving an ionic compound, like I said, you get ions, but the ions will always be in the aqueous state, okay? So whenever you have an ionic compound, and you want to like write the equation for it, the products or like the ions that you get out of dissolving it, they're always going to be in aqueous. Okay, here it's fairly simple. You just look at the coefficient beside like the molecules. Okay, so here we have N2, which is 1 because it doesn't have any number before it. Here we have 3H2, so 3 molecules of H2. And then here we have 2 NH3, so 2 molecules of NH3. Okay, here. This is also fairly simple. Do you see any number, any coefficient beside AG? No, I don't see any. So it's only 1. Here beside NO3, do you see any, what is it called? Any number? No, so it's only 1. If you see 2 beside AG, so that means it's 2 moles. If you see 3, that means 3 moles, so on. Okay. This is just memorization, understanding, mostly memorization. Okay, a solution in which the solvent is water is called an aqueous dissolution. Aqueous means dissolved in water. So whenever you have a solution which solvent is water, that means it's an aqueous solution. Okay. This one is also simple. Many people might not see it, but it's very simple. Okay. A molar concentration of a solution yani it's dissolved in something. Okay. So molar, moles, so it's the number of moles. Solute per liter. Okay, I tell you why it's per liter, because here it's a solution, so it's dissolved in a liquid. Okay, so it has to be like some sort of liquid. Liquids are measured in decimeters, liters, and so on, so that's why it's liter. Okay, this one's basically memorizing, but I'll help you understand why. Okay, weigh 58.5 grams of pure NaCl. Okay, here they're telling you weigh something. We have to forget about this because when you're solving the quiz, they don't give you answers. Okay, so weigh a blank of pure NaCl. Here they give you Na and they give you Cl. So add them up, you get 58.5 grams. So you fill that into your blank. Okay, here they're telling you add the salt to about blank of distilled water placed in a 1.00 liter. Okay, here they want for you, okay, whenever you're mixing a solution or making a solution, first thing you have to mix the solute with a bit of solvent just to make sure you have it all mixed up, because then at the beginning, if you add all the solvent you have, you're still gonna feel some tiny greens. Okay, so it has to always be a bit first, and then you put all the amount. Okay, so what's a bit here? We have for liters, because we need liters, because water, liters, liquid. Okay, we have 250 milliliter, 1000 milliliter, and that's it. Okay, 1000 milliliters equals to 1.00 liter. Okay, 250 milliliter equals to maybe like 0.25 something. Okay, so that's gonna be, because that's less than 1 liter, so that's gonna be your answer. And then we have to place it in something. What can we measure with? We have beaker. You can't measure stuff with a beaker. Volumetric flask and measuring cylinder. Okay, the best like container, whatever you want to do with, to use is volumetric flask. And this, for me, I like to memorize it because I don't understand mostly why you don't pick measuring cylinder. But the most like the better choice of apparatus is volumetric flask. Okay, like I said, first you have to add a bit to your water to your solute, and then you add all of it. So here they're telling you add more water to make Exactly. You can't have approximately. You have to have exactly 1.0 liters of NaCl solution. Okay, so for this question, they're telling you 2.0 liters of 1.0 m, which is concentration, NaCl solution is prepared in a flask. 400 milliliters of the solution is poured out of the flask into a beaker. What is the concentration of the salt solution in the beaker? Okay. Here, they're telling you that they poured 400 milliliters of the 2 liters. But they didn't tell you, they're asking you to tell them how much the concentration there is there. Okay, so let's think real life. Okay, when you're making juice, you know the powdered juices? You take a big like bottle or whatever, you put the powder, you put the water, you mix it well, and then you add more water. That's what that other question was, okay? So when you put that water, more you put them into small cups to like give other people, the concentration will still be the same. It's just smaller amount of liquid in each cup. So our concentration will be the same, but our liquids will be smaller. That's it. Okay, so in this question, they're telling you to check the correct definition of the solubility of a solid S at a temperature T. Okay, here they're telling you 1 molar solution of S at T temperature, T Celsius. That does not make sense. Density of a solution at no. The minimum mass, no, it's maximum mass, like I told you in the other video, the other question. So none of these are correct, okay? Okay, so what we have left is the concentration of a saturated solution of S at T temperature. That sounds the most like right out of all of them, and it makes the most sense. So we pick it, and it's like pretty easy. It's like pretty explanatory. Okay. From the periodic table, you can like see what compounds are a ionic compound and what compounds are molecular compound. Okay. Here, ionic compounds are made up of a positive element and a negative element. Unlike molecular compounds are made up of 2 alike elements, okay? So, Ca and Cl2, Ca is plus. I don't know how much plus because I don't have my periodic table in front of me. And Cl is minus something. Plus always comes before minus. All I know is this is an ionic compound, okay? And then sugar, it's C6H12O6, okay? I'm telling you that sugar is a molecular compound. And CaCl2 is an ionic compound, okay? Let's remember that for this question. So here they're telling you CaCl dissolves in water to form a solution that something electricity. Okay, ionic compounds form ions which make a charge. So they do conduct electricity. Okay? Okay, so they conduct electricity. But sugar dissolves in water to form a solution that does not conduct electricity because it's a molecular compound. Molecular compounds do not conduct electricity. Okay? This is because unlike sugar, because they're not the same, CaCl2 and sugar are not the same. When CaCl2 dissolves in water, it forms ions that allow the electric current to flow. Electric current, that means it conducts electricity. Okay? Okay, for this question, they just didn't write anything here. Okay, and they asked you to balance the equation. Okay? So, here we have 2Na. Here we have 1Na. So, we have to put a 2 on top, on it. Okay? Here we have CO3, CO3. So, the C is 1. So, here the C is also 1. And the O is 3. And here the O is 3. So, the only missing number is 2 in front of the Na. So, it's 2Na plus. Okay, this is new stuff we took last year, okay? Okay, so last week or whenever you studied this, we learned the terms predominant ions or predominant reacting species and spectator reacting species, okay? So, spectator, from the word, you can understand that they're spectating. Spectating means they're looking and that's all they're doing. They're not playing, they're not doing whatever. They're just looking and like looking at what's happening, okay? But predominant means they're participating in the reaction or in like whatever they're doing, okay? So here they're asking you, species that participate, the keyword is participate. And what did I say abishwai? Participate means predominant reacting species. Okay, here they're asking you for fractionating column. Fractionating column is always the one under the thermometer it's always there in fractional distillation, okay, and it's always under the thermometer. So that's the first part. You have to press on that, okay? The second part, what if through about fractionating columns, you have to memorize this. It is used in simple distillation. No, it's used in fractional distillation. It's a long vertical tube containing obstacles and only cooled by air. Yes. And then it is an apparatus that uses water to cool vapors and condense them into liquid. No, it's only obstacles. Just remember it. It looks fun. Obstacles. That's a fun word, you know. So just memorize it by that. Okay, here is when we're going to use our calculator. Okay, we have to memorize. I use it as a pyramid because it's the easiest way. So here it's N. Wait, N. And here it's CV. Okay, let's remember that. Whenever you see the big M here, that means it's C, which is concentration. Okay. So for the equation for C, from the pyramid, it's C equals, as always, the pen is not working. C equals NV, N over V, because here we have N over V. So N, oh my goodness, N over V. Okay, so the N of this question is 0.50. So we'll put 0.5, same thing as 0.50. 0.50 actually, not 0.5. Over, the volume is 1.0 decimeters. It has to be, in decimeters, in liters. It cannot be in centimeters cubed or whatever, okay? So 1.0. So on your calculator, 0.50 over 1, or you can do it mentally because this one's literally so easy. It's 0.50 m, which is concentration, which is the unit for concentration. Okay? Second part. Like I said, remember the table. I'll change the color so you can see it more clear. C over NV. Okay? So, here they're asking for N. So, N equals CV. Okay? So, here the V is 0.10 and the M, which is C, times is 0.50. So 0.10 times 0.50, this I don't think many people can do it mentally, is on your calculator is 0.050. Okay? And make sure you look at the question and how many significant figures they're asking. Here they're asking for 2 significant figures. So, third part. Fourth part might be like the most confusing out of all of them, okay? So, third part, let's draw the pyramid again. Oh my goodness, okay. Change the colors, N, which is moles, over C, V is volume, C is concentration, which is M also. Okay, so here they're asking for volume. Okay, so V equals N over C. Our N here is 0.1 mole, so 0.10. Why do I keep hearing 0.1? Sorry. And then the C is 0.20 concentration, which is M, so 0.20. On your calculator, you put 0.1 over 0.2. Okay, on your calculator, if you do 0.10 over 0.20, you get 0.50 decimeter cubed. Okay, now in the fourth part of this question, they're asking you to tell them the mass of the mass in general, okay? So let's write all the rules we'll need to use, okay? We're gonna use 2 pyramids in this question. And then the first one is the one you've been using, N equals CV. And then the second one is M over N, the big M, which is molar mass, okay? So first thing, we'll find moles. Where is we find moles, so we can find mass, okay? So let's use pink, okay? So N equals CV. C is concentration, which here we know it's 0.1. So 0.1, 0.100 or 0.10 times volume, which is 100 centimeter cubed. Centimeter cubed 2. Wait, let's make that clear that it's a 3. Okay. 2 decimeter cubed, or liters. Liters and decimeter cubed are the same thing, okay? So that to that is divide by 1,000, okay? So 100 divided by 1,000 is also 0.1. So the moles is 0.1 times 0.1, which is 0.01, okay? So 0.01 moles, okay? Let's write our table again because it got erased. M over N, and then big M. This is supposed to be a small n. Wait, this is a small n, by the way, small m. Okay, and this is the n, and this is the big M, which is molar mass. Okay, so we found moles. Now we need to find the mass, and we know that mass equals moles times molar mass. Okay, so since we have our moles, which is 0.01, let's find our molar mass. Here, sodium carbonate, they're supposed to give you like the equation or whatever it's called for sodium carbonate. I'll give it to you. It's Na2 CO3. Okay, so Na, we have 2 of Na, so 223 plus 1 of 16, 1 of C, so it's 12, and then 3 of oxygen, so 3 times 16. On your calculator, if you do all that, I think you get 106, but let's check on my calculator. 223 times plus 12 plus 3 times 16, and you get 106. Now let's multiply 0.01 times 106. You get 1.06, and that's your mass, grams, whatever. And remember, if you ever have a written exam, you have to put the units. Okay, this, we also have to balance the equation. We don't have to do anything else. So, in this equation, they give you 1 of Fe, so this is fine. And then Cl3, they give you 3 of Cl, and that's fine. Which was I supposed to do? Wait. I guess in this question they asked you aqueous. What do you have to put as that? Okay, to be honest, I don't remember what they asked in this question. So let's just figure out everything, okay? They're giving you FeCl3 L cubed, okay, S. And they want you, I guess, to write this part. So let's erase it out and try to figure it out by ourselves, okay? You don't really need a periodic table for these types of questions, okay? You can find them like by common sense, okay? So this compound is made up of Fe and Cl, not Cl3, okay? Because Cl3 is Cl in nature, okay? So Fe is always going to be positive, and Cl is going to be minus, because like I said, plus first and then minus, and it's an ionic compound, so it has to be negative and positive, okay? And then we have 3 under the what is it called, under the Cl, so it has to come out of somewhere, okay? So we use a method called the butterfly, I think it's called, yeah, it's butterfly, which is cross multiplication technically, okay? And whatever we have here, we add it here, like in this spot here, and then whatever we have here, we put it to this spot. So if this was just plus and minus, it will be here 1 and here 1. But for example, let's say this was 2 and this was 3. The number always has to go before the sign, by the way. So when we do the butterfly effect, this will be Fe3 and this will be Cl2, okay? So that's how you find what's under the element, okay? So this question, they told you that we have Hone 3. So where did we get that 3 from? From Fe. So Fe is 3 plus. And here we don't have anything under the Fe. So it's 1 minus, which is minus the same thing. And then butterfly effect, you get FeCl3. So when they're asking you to do that, you just fill them in, okay? And then since you need to balance it, you have to put 3, 3, okay? Then it's always aqueous, products are always aqueous since they dissolve in water, okay? Okay, this came so many times, okay? But this never came in any exam, so let's just still do it, okay? Okay, so let's start. They're telling you to find the number of moles of zinc, okay? They're already giving you, and moles is N equals M over M big, okay? So they already gave you the mass of zinc, which is 0.109. Let me fix up the 1. Over, and we know the molar mass of zinc because of this is 65.4. Put it on your calculator, you get 1.6666666 so on times 10 to the power of negative 3. We round it up to 3 significant figures. You get 1.6, and then 6 to 6 is 7. So 1.67. So 1.67 times 10, oh my goodness, 10 power of -3, okay? And that's what we put in the first choice. Now they're asking you to calculate the number of moles, okay, of hydrogen gas collected, okay? So for me, I like to use the given in case we got this question wrong. I like to use the given, okay? So the first part, we have we use GR for this part, okay? So the RR is 65.4 because it's only one zinc. If it was two zincs, you multiply by 2, okay? Over the GR, which is the given, which is 0.109. They want us to find the number of moles of hydrogen. Here we have 1 mole, so cross multiply. You also get 1.670 times 10 to the power of -3. So it's literally the same answer, okay? Then here they're asking you to find the total volume of hydrogen gas released, okay? So total volume at RTP is 24, okay? So total volume, so we use the moles, which is 1.67 times 10 to the power of -3 times it by 24, you get 0.04008, okay? They're telling you it's in centimeter cubed, okay? So we take 0.04008 and you multiply it by 24, you multiply it by 1000. I mean, you divide, sorry, because when you're going from centimeters to decimeters, you divide. So divide 1000. You get 40 point something, whatever, okay? And here, this is the only one with 40 on like the line. So that's that. Okay, for this one, whenever the arrow is going down, it's a exothermic reaction, and whenever the arrow is going up, it's an endothermic. Here, the arrow is going down, so it's exothermic. We know exothermic releases energy, and endothermic absorbs energy, okay? So that's the first part. Now the second part, 1 mole of water is produced. 284 kg of energy is, since it's exothermic, that means it's released, okay? Here they're telling you, what is the amount of energy involved when 0.50 mole of hydrogen gas are consumed, okay? Here, we go back to this, okay? Hydrogen gas is here. So when we had 2 hydrogens, the amount of energy was 284. So now they're asking, how much energy will we get when it's 0.5? So we multiply 284 by 0.5 and you got 142. Okay? And that's your answer. This is very simple. Since it's a gases occupy the whole volume of whatever you put them in, okay? Gases have nothing fixed. No fixed volume, no fixed shape, no fixed anything. So whenever they go into a container or a vessel or whatever, it's gonna occupy the whole thing, okay? So here they're telling you a rigid sealed vessel contains a mixture of 3 different gases kept under the same conditions of temperature and pressure. The volume occupied by each gas is equal to the total volume of the vessel, because I told you they occupy the whole thing. Even they're trying to confuse you here by telling you there's 3 different gases. That doesn't matter, because gases can, like, if you have like 100 gases in one place, they can still occupy the whole place, okay? And that's it for the AMS week 8, chemistry AMS.